Thanks, Todd. I really appreciate it. Appreciate all the kind words. And again, honored to always present at your meetups or conferences because they are world-class, and truly appreciate all the time and effort your team goes into putting these events together. So I want to give you a huge shout out there, and really looking forward to the new All Things Open hybrid event. I think that's going to be a lot of fun. And welcome everyone. Again, I wish we could do this in person. And I know we've got a little bit of a time crunch, so I am going to go pretty fast because I have a lot of content to cover, but I'm going to skip over some sections that I think I can address either offline or via questions as well. Let's see if I can pull up the Q&A. Got it. So this is a talk about APIs, and I really wanted to put together a talk about things that you should think about when you build APIs. Things that aren't necessarily super obvious as you get started. If you understand what an API means, you will see them everywhere. Twitter, Dropbox, YouTube, Stripe, AWS, Google Cloud Platform. Basically, modern computing, the cloud is built off of APIs. They are everywhere, and there are whole companies that are nothing but APIs, like Stripe and Twilio. So it's an important concept. Zapier is actually a company that connects APIs together, which is really cool. So you can have an API from Stripe and an API from Twilio and use Zapier to integrate the two without having to write code. So I like to think about APIs, kind of as the way of describing the functionality of your application, right? So if you have a well-designed API, you have a well-defined application. A traditional application, you have kind of a client-server model, and then there's a lot more depth to this. You have an API, whether you know it or not. It could be in the form of REST or JSON, or it could be in the form of, just kind of business rules inside your monolith application. And then you kind of have these services, and services could be databases, could be APIs, right, to SMS services or Amazon Web Services, etc. So when I say client server, we're really talking about more than just a browser and a cloud server. We're going to cover 5 sections, and like I said, we'll probably go a little bit fast between some of the ones that are probably common knowledge, and I want to spend a lot more time talking about documentation, validation, and testing. And these are requirements, and specifically non-functional requirements. So if anyone knows what the difference between a functional requirement and a non-functional requirement, that would be cool to shout out in the Q&A. But we're going to be talking about non-functional requirements. So let's go to documentation. There's 3 kinds of documentations we'll discuss, and then validation, a little bit different than maybe something you're akin to, and then testing, specifically integration testing, and then we'll touch on monitoring as well. So for the context of this talk, we'll be talking about REST JSON APIs, but this really applies to GraphQL or RCP, RPC, any kind of interface between systems, and it could be even within the same system. But we'll talk about REST and JSON because they're the most common on the internet. So with security, there's really four areas that you have to focus on with security, and obviously security is super important for applications, especially APIs. The first thing is everything needs encryption with SSL certificates, and because we live in this open environment, there's a great company called Let's Encrypt that makes this very easy to do. In the past, this used to be a pain. It's still a little pain now, but not nearly as bad. And then you have kind of authentication. And a common authentication mechanism is a JSON web token for APIs. The JSON web token is in three parts. It's a header, a payload, and a signature. And it's not encrypted. So that's one important thing. So you want to be careful what you put in your payload. Payload is where you put the information that your API needs to determine if this particular request is authenticated, and we can use the signature to verify that this token was generated based off of a secret or a public key or a private key that can't be replicated. So this is a great way to ensure that the requests coming in are what you expect as an API. And then you have authorization. And authorization, I like to model them as scopes. And that really means that you're not focused on the who, you're more focused on the scope that particular requester has, right? A resource and an action. And if their scope is kind of star : star, then they have kind of access to everything. If their scope is resource, like movie : read, then they can only read the movie's resource, or they may have a resource review : write, and they can write movie reviews. Or finally a comment and : delete, where they can't create comments, but they can delete them. So that's kind of an example of a scope that would go in your JWT payload, so that your API is not thinking, well, is this user Tom Wilson, or is this user a part of the admin group? It's thinking, my API endpoint allows you to read movies, and I want to verify that your scope gives you that access. And that kind of gives you this table where you can have a very general purpose API, and then you can assign these scopes to users and roles in your authentication system, and creates a really good kind of way to organize that. Yeah, I'm going to skip through this, but this kind of goes into the kind of how you can have roles and different kind of scopes. Documentation, the topic that every developer loves, right? Loves to hate. So we don't like writing documentation, but we definitely don't like reading bad documentation, or we don't like no documentation. So when you're building APIs, documentation is probably, besides security, it's probably one of the biggest and most important things to really pay attention to with APIs, because your customer or your users of your API are developers, and they need to know how to interact with your API. And in kind of three areas. One is, I'm a developer and I need to know how to contribute to your API. So I need a README, describe what your API does, links to any documentation externally, but this README should be your kind of gateway for the developer that's going to be working with your API, contributing to it, setting it up, deploying it, etc. And then the next piece is, skip it, yeah, Swagger, our open API. And these are reference documents, right? And open API is a common standard out there for REST APIs that define how you could, how you can specify all the logistics of calling your API. You describe how people authenticate, what servers your API runs on. The endpoints, I can do a get root or a get widget, right? I can do a post widgets and create a new widget, provide examples, provide common components and models. It has everything you can do in this YAML or JSON format, and then it can generate a UI like this, right? Here's the example of kind of the Swagger UI, where you can view this online and the developer can kind of go through this UI and get all the information they need to know how to submit a request to your API to interact with it, which is huge. And it the nice thing about this is that it guides your not only putting your API as an end result of having documentation, but it guides your design of the API, because by filling out this contract, you're actually thinking more, do I need to support a 404 status code if someone calls this URL and it's not found? Or do I need to support a 409 status code of a conflict if someone tries to send a new document to the same identifier? So that's great, but really what takes your documentation over the top is getting started in user guides. Any API you'll go to, you will see a big getting started button, right? Or how do I use this API in this use case? Those are very important questions to answer for developers. And oftentimes they're not looking for, hyper the magic service. They're trying to solve a problem, and they're just trying to determine if your API solves that problem. So they want to see things in terms of use cases and guides. Here's an example from Twilio, programmable SMS quick start for Node.js. And it just steps through. Here, we're going to teach you how to do programmable SMS with Twilio and Node.js. And it gives the user a specific use case that they want to accomplish so that they can onboard to that API as quick as possible. So that's pretty cool. And yeah, George, I just saw your question. And just to answer really quickly, at the end of the talk, I'll have a link that has a whole bunch of references that talks about books and blog posts and other things that you can go deep in with APIs. So I think that will help. Here's another example of Twilio SMS. I think it's just zoomed out. But, talking about a specific use case here for sending out time-sensitive alert messages for developers, right? So if you are working a development team, you might Google, how can I send alerts out? And hopefully you'll hit this kind of user guide, onboarding guide for Twilio. And you can quickly see how you can leverage their API to do that. So that is documentation, and could spend hours on documentation. But another part, and this one is not very not talked about enough on the internet, I think, is validation. So we do talk about, as developers, validating our data models and adding validation in kind of the data layer, but I don't think we talk about validating data coming into your API, even if it's your own client that's sending you data. Never trust the data coming from the client. Never, ever, ever trust the data coming from the client. Just by validating that data at that point from where, kind of this internet hits your application process, you can save so many bugs and problems for for your business logic and your data, and reduce a lot of potential security holes. And you don't have to build this validation all yourself. You can use validation libraries, and you can be very concise and concrete, right? So like if you have a model that takes a name, for example, you can say only make that name 50 characters and only allow these alphanumeric characters for that name field. And you can always relax that later, but by really checking that input can again give you a better handle on how clients are interacting with your system. Some example validation libraries, a relatively new one called Zod. If you follow Superman, one of his enemies is Zod. Us developers always have just the best naming practices when it comes to projects. So we have Zod, and then we have Joy, spelled with an I. That's a very popular one in Node.js community. Recommend checking that out. And then finally, if you need to do validation on the server, there's a great library called Yup. So validation libraries, Zod, Joy, and Yup. Great names, but they're very helpful. They give you a nice kind of domain-specific language to be very concise and very clear on how you're going to accept data into your system. So I highly recommend using these. Zod interacts with TypeScript. So if you use TypeScript, Zod can actually allow you to create schemas and save them as types. So that's really kind of cool. Let's see. Validating your output. Now, this is something that you very rarely see, but not only should you not trust your clients coming into your API, but when you make a call to a service like a Twilio SMS, or maybe an Amazon web service database, or maybe a queue, whatever, those are also kind of external boundaries that you need to make sure that data is coming in the way that you expect it to come in. So don't be afraid to validate your services to make sure that your data is coming back from those services that are correct as well. Again, that can reduce kind of middleman problems, or any kind of injection from your service layer. And it can provide valuable information for troubleshooting, right? So if you know that you've got really strong boundaries between your service layer and your interface layer, then it makes it easy to find bugs. It makes it easy to find what's going on. And the last, kind of topic that I want to go deep in is testing. And in 2021, I think testing is kind of common practice for every development team, but it can also be kind of a challenge of knowing what to test, how to test, what test do I use to get the best bang for my buck. And I want to talk about integration testing. So what is integration testing? Integration testing is the process of testing kind of from one point in your application to another point in your application. Whereas like end-to-end testing is testing as if you're the user, and you're testing all the way to the end to your service layer and back. And then unit testing, you're testing kind of a specific component or a specific function. I believe in this day and time that integration testing, especially for APIs, really give you the best bang for your buck. Unit tests are great. You definitely should do unit tests for complex calculations and complex business logic. And end-to-end testing is great, but it can be slow and brittle, right? So if something changes on one side or something changes on the other, it can create a lot of effort to keep those up to date. So I believe integration testing is kind of the sweet spot. And the way that I like to explain integration testing is kind of you're focusing on your business logic, the thing that makes your application different from the rest of the world. The client, everybody has a browser, everyone has a mobile app. On the services side, everyone has a database, everyone has a cache or has a search engine. But what you're bringing to the table with your application and API is kind of in between. So creating this kind of container where you make the request to your API, and then your API does some work, and it may talk to a service, mocking out that service layer and returning data can create a very nice environment so that you get automated, reliable tests that run fast, and they really test your code and can help you find bugs quickly and can help you do TDD or test-driven development, where you're writing the test before you actually write your code, which is another pattern that works really well. So here's an example, and it's a lot of code, and I don't expect you to read all of it, but basically what's happening here is we spin up an actual server per test, and then we make a call to that server. And then when that call comes back, we validate that result, and then we close the server down. And here we can attach mocks to test the back end. So, being able to start a server and kind of call it from the API is huge. And then being able to mock it by, in this case, we're taking the global fetch and creating a little wrapper around that so that we can say, you know what, when we get this request, example.com, then we're going to return a 200 back. And then now our tests are really testing from the API endpoint all the way to the service call and back. And that gives us the ability to make sure everything inside our application is talking to each other well. And then the last piece is automation. So automation is super important in terms of really creating quality. It's kind of funny. A group called Dora did research on how to improve software quality. And one of the biggest driving factors was continuous deployment. Continuous deployment is the ability to deploy multiple times a day, right? And in order to do that, you have to have a lot of confidence in the reliability of your code. So you have to have some tests. And then what you want is when something is added and it's pushed into version control, you want something that's going to run all those tests and give you high signal if something breaks. Here is an example of a GitHub action. GitLab has CI. Jenkins has CI. All of these things can help you run continuous tests as you work on your code. And then the nice thing about that is that makes the deployment step much easier, because you know that you've got these tests, these integrated tests running every time you make a change or every time you do a review. Cool. So I'm going to stop there and look at some of the questions. So Kevin asked that he works in cryptocurrency, and on research sites, they offer connecting to their API for use on my website. I am not a coder or a developer, so I don't understand how I can use this. How can I find someone to help? So I would recommend looking at the Get Started guide, and then also looking for forums for that particular API. Oftentimes there's forums that people that are not coders or developers, you can go to and ask questions. And then some people that are coders and developers can connect with you, and you can make connections to work with. If that particular API doesn't have something like that, then I would recommend looking at some developer contract service groups that you can basically rent a couple hours of a developer's time to help you figure out some stuff. Another question is developing a website that can create a platform that can take advantage of info coming through these APIs. I think that was just a continuation of that one. And then George asked, can you please recommend a good book that covers topics? And so I'll have some resources at the end to talk about that. So the last topic I'll go really quick is monitoring. And monitoring is super important because you do need to have signal on what's going on and really good signal of where something is happening. So application performance management basically allows you to plug in a bit of code in your API, and it's going to monitor the memory, the CPU, and response time for each endpoint. So you can see if the endpoint is really taxing the system, or if it's returning errors, or if it's using a lot of memory. And that can give you a lot of signal on how people are using your API at scale. The other type is log aggregation. And log aggregation is you may be familiar with console log. You can actually organize your logs in terms of info, debug, error, and other kind of events. And then you can actually search and filter those logs based on those messages, which can give you, just the right kind of density that you want when you're monitoring software. Here's an image of a dashboard that you can create when you apply APM and logging. So you can kind of create this whole view of your API and see what's going on in real time. So that is it. Again, I would really, if you take anything away from this talk, really dig into documentation and dig into validation. Those are kind of the two that I don't think are really stressed enough when it comes to APIs. And if you want to know more, I talk a lot about APIs over on the Hyperblog. So subscribe to the Hyperblog or check out our channel on YouTube with hyper63 or follow me on Twitter. We are building a service that serves APIs of all kinds of use cases, and we'd love for you to check that out if you're interested. So thanks again for your time, and I don't see any more questions in the QA, so I'll pause there. Jennifer, Todd, is there any questions that I haven't answered?
Tom, I think, oh, sorry, Jennifer, I hope I didn't cut you off. Sorry about that. I saw that Phoebe raised her hand. So I tell you what, we don't generally do sort of raise your hand, enable microphone type questions generally because the time is just so compressed. But with this one, we do have a few extra minutes. So if you are interested, Phoebe, Phoebe, if you appear to still be on, could you raise your hand again?
She said she didn't mean to raise her hand.
Oh, she
Oops, accident. It's okay, Phoebe. But Gail Brown does have a question for Tom. It said, and she said, it seems that when it comes to monitoring, some managers consider it resource consuming. Does API fit in this situation?
There are some monitoring tools that could consume resources, but there's some good tools that don't. There's a lot of great open source tools that that don't require significant resources. Elastic, for example, makes some tools, and then Amazon and Google's platforms both have some tools. So if you, and Azure, if you use those cloud vendors, then you get a lot of monitoring for free, and they don't consume a lot of your resources, or consume extra money, if you will, to spend to monitoring that. But again, when you are building applications in this day and time, there's a lot of other things you can't control, and having good monitoring tools can at least allow you not to spend significant time fighting or troubleshooting something that's not even within your control. For example, if you're running an API and all of a sudden the API is slow, it may not be anything to do with your API or your cloud, et cetera. It could be an internet connection between that client and your API. And without monitoring tools, you may not know that. So I think that they really pay for themselves.
Okay, Tom, I think that's a pretty good response to Gail's question. Gail, if you have a follow-up or any follow-up communication or comments or anything like that, please let us know. Let's see, Jennifer, do you see any other questions, or are there any other comments or anything?
I don't see any.
Oh, okay. Yeah. All right. I was just looking back over the Q&A stream and the chat stream and things like that as well. Okay. Well, that's good. Okay. So let's see. Tom, any final words or parting comments or anything like that before we wrap it up? And we'll do just a few sort of wrap up community announcements again, and I'll repeat a few things that I stated there in the very beginning for the benefit of everyone that was not online at that time.
Yeah. Thanks for the time to talk. I really appreciated it. And APIs is a huge subject. There's a lot of things to dive deep on. So I'll make sure I'll share my slides with you, Todd and Jennifer. And again, I've got kind of a resources slide at the end that allows people to take this is the toe in the water, to take the journey to go deep into the pool. So, and then I'm always happy to talk to anyone if they want to learn more.